Hey folks, today we will talk about IMS architecture and understand how IMS network facilitates a VoLTE call. We will see what is the role played by various LTE and IMS nodes during a VoLTE call. This is the IMS architecture diagram taken from IMS specification. It may appear a bit scary at this moment, but believe me, we will dissect it step by step during this video. At the end of this video, we will again refer to this diagram and see that this architecture can be explained in 2 minutes. Let's move on. What is IMS? IMS means IP Multimedia Subsystem. IMS is a framework or architecture that comprises of many technologies. Its biggest advantage is that it is standardized by 3GPP. So any other standardized network, such as LTE, 3G, 2G, PSTN, Internet, can connect to IMS and use its services. This is LTE network. I would assume you already know basics of LTE architecture. If you have any doubt in LTE architecture, I would suggest you to go through my video on this topic and come back. This is PCSCF present in IMS. PCSCF means Proxy Call Session Control Function. UE has to communicate with all other IMS nodes via PCSCF. But interestingly, when a LTE UE is switched on, it does not know anything about PCSCF IP address. So, how does a UE talk to PCSCF? There are 2 ways for an UE to get IP address of PCSCF. First, UE can request the PCSCF address in the EPS attach or PDN connectivity request message, and PDN gateway will send the PCSCF address to the UE in PDN connectivity accept message. Second way is, UE can use DHCP procedure for PCSCF discovery. In this case, PDN gateway acts as DHCP relay agent, relaying DHCP messages between UE and DHCP server. What is the role of LTE network in facilitating VoLTE call? See, the main job of LTE network is to provide IP connectivity to the UE. UE uses this IP connectivity to exchange SIP messages and user plane data with IMS network. Let me explain how it is done. We already know when an LTE UE is switched on, it always set up a default bearer with QCI 9. APN used for this bearer varies from network to network based on network settings. This bearer is used for internet access. All the LTE capable UE make this default bearer for internet access. So, this default bearer is not something new. But here is something new. VoLTE capable UE makes one more default bearer with QCI 5 for IMS related signaling. APN used for this default bearer is always IMS. Now UE has 2 default bearers, one for internet access and another for IMS signaling. UE exchanges SIP messages with IMS network by using user plane of this bearer having QCI 5. SIP messages from UE will go to PDN gateway and from PDN gateway to PCSCF present in IMS network. Remember, IMS bearer cannot be used for communication with any other PDN. This bearer is dedicated only for communication between UE and PCSCF. Here is one very important thing to notice. SIP messages sent by UE are part of user plane for LTE network. The role of LTE network here is just to deliver SIP messages transparently from UE to IMS network by using the user plane of IMS bearer. Here, transparently means LTE network does not decode any SIP messages and sends them transparently to IMS network. We know PDN gateway is the node in LTE responsible for exchanging UE's data with external world. PDN gateway plays the same role when UE needs to talk to IMS. The SGI interface at the PDN gateway acts as a user plane interface of LTE network towards other networks such as IMS, Internet, EUTRAN, UTRAN, and other non-3GPP networks. Remember, SGI is an IP-based interface. PDN gateway is connected to PCSCF present in IMS through SGI interface. SIP messages from UE come to PDN gateway as user plane data of IMS default bearer, and PDN gateway sends them to PCSCF over SGI interface. IMS reference point between UE and PCFCF is GM. But do remember, there is no direct link between UE and PCSCF. All the SIP data from UE to PCSCF goes via PDN gateway and over SGI interface on IP transport. PCSCF is connected to PCRF and LT network through RX interface. PCSCF uses the RX interface to inform PCRF about the need for establishment of dedicated bearer for video or audio call data flow. PCRF further talks to PDN gateway, and then PDN gateway triggers establishment of dedicated bearer for user plane of voice and video call. This dedicated bearer has QCI1 for voice call data and QCI2 for video call data. Remember, SIP is used for control plane in IMS, but for user plane, other protocols such as RTP, RTSP, etc. are used. Let's now go inside the IMS network and see what are the various roles played by different IMS nodes. The proxy CSCF is the first contact point on IMS network for UE. Here, proxy CSCF means proxy call server control function. The PCSCF behaves like a SIP proxy. It accepts requests from UE and services them internally or forwards them onto other IMS nodes. The functions performed by PCSCF are forwards the SIP requests and responses from other nodes and peers to the UE and vice versa, maintains a security association between itself and UE, performs SIP message compression and decompression, does authorization of bearer resources and QoS management. PCSCF is connected to ICSCF. ICSCF means interrogating CSCF. Its main functionalities are allocates SCSCF to UE at the time of registration. Here, SCSCF means serving CSCF. When UE triggers IMS registration, ICSCF interrogates HSS to find a suitable SCSCF for this UE based on UE's and SCSCF's capability. Then, ICSCF forwards UE's registration request to this SCSCF. Its second main task is, when there is a SIP message destined for a UE, ICSCF determines which SCSCF and UE is registered to by interrogating HSS and forwards that SIP message to correct SCSCF. Now, serving CSCF. As we discussed earlier, SCSCF is assigned to an UE at the time of registration. A serving CSCF performs the session control service for an UE. Main functions performed by SCSCF are, at the time of IMS registration, it acts as a SIP registrar. It means SCSCF receives registration requests from UE and makes all the required entries for this UE in HSS. The SCSCF notifies subscribers about registration changes. SCSCF also forwards the SIP requests or responses to corresponding domains. Let me explain this point. SCSCF checks the domain present in a SIP request. If a request is destined to CS domain, SCSCF forwards this request to BGCF, or if a request is destined to another IMS network, SCSCF directly forwards this request to IBCF. Next point, checks whether UE has the valid subscription for IMS service it is trying to use. May behave as a proxy server, that is, it accepts requests and services them internally or forwards them on. May behave as a user agent, that is, it may terminate or independently generate SIP transactions. Remember, PCSCF, ICSCF, and SCSCF are just the logical nodes. Practically all these nodes are present in a single physical node called CSCF. In a nutshell, we can say that CSCF is our SIP server. SCSCF is connected to application server through ISC interface. IMS application servers are used to provide a specific service to an user. These services could be audio or video conferencing, multi-party gaming, presence, content sharing. One application server can host multiple IMS applications. Let me explain purpose of application servers with the help of few examples. Audio conferencing is the excellent example of IMS application running on an IMS application server. When an user dials for audio conferencing, this call is received by an IMS application responsible for audio conferencing. Then, this application asks user to insert the conference pin. If entered pin is valid, application allows user to join the call, otherwise it asks user to retry. Parenting control is another example of IMS application running on an application server. In this case, application checks whether user is allowed to make a call to the dial number. If he is not allowed, then IMS application will not let call go through it. Now there could be a question that who will decide whether application server should be consulted when a call is being established. Actually, SCSCF decides whether it should forward an incoming SIP request to the application server or not. UT interface. The UT interface is an interface between the UE and IMS application server. The protocol used on UT interface is XCAP. XCAP means XML Configuration Access Protocol. Let me explain purpose of this interface. As users' data related to value-added services is stored in application server in the form of XML files, XCAP protocol on UT interface allows user to update users' data related to value-added services at application server. For example, for call-bearing services, mobile can directly update the mobile numbers to be barred at the application server end via UT interface. So, if there is a terminating call for the UE from this barred number, IMS application running on the application server will never let this call pass through it. But let me clarify, UE cannot directly talk to application server. All this data goes via PCSCF. BGCF means Breakout Gateway Control Function. BGCF decides how to route telephony sessions initiated in IMS network and destined for a circuit switch network. Here, CS network means PSTN, 3G, and 2G network. If the BGCF determines that a breakout is to occur in the same network in which the BGCF is located, then BGCF shall select a MGCF which will be responsible for the interworking with the CS network. If the breakout is in another network, the BGCF will forward this session signaling to another BGCF in the selected network. MGCF and IMS Media Gateway. MGCF means Media Gateway Control Function. Media Gateway Control Function and Media Gateway are responsible for the control and media plane interworking to the circuit switch networks. 3G, 2G, and PSTN are examples of circuit switch networks. Voice bearers from IMS need to be connected with the voice bearers of the circuit switch network. Nodes such as Media Gateway are provided to support such bearer interworking. One of the functions of Media Gateway is to support transcoding between a codec used by the UE in IMS network and the codec being used by other party in CS network. The Media Gateway interconnects the circuit switch network with the packet switch network by converting RTP packets from IMS network into the CS correspondents and vice versa. IBCF means Interconnection Border Control Function. The IBCF is responsible for interworking with the peer IMS network. So, IBCF will have its role to play whenever source or destination of a VoLTE call is in some other IMS network. The IBCF controls one or more transition gateways to provide appropriate resources in the user plane. IBCF invokes a transition gateway to allocate and configure media resources for the call. The transition gateway is an IP to IP gateway and serves as a border element in the data plane in an IMS network. Also, transition gateway provides the necessary function for codec transcoding, but transcoding shall only be performed only in case when a common codec cannot be negotiated between two UEs. The MRF is a common media resource function used by IMS application servers and SCSCFs to provide media plane processing independent of application types. MRF is divided into two components, MRFP and MRFC. MRFP does the media-related processing, and MRFC is used to control MRFP. Its main functionalities are multi-party conferencing, network announcements, transcoding, IVRS. IVRS means Interactive Voice Response System. MRB. MRB means Media Resource Broker. Purpose of MRB is to select appropriate MRF from MRF resource pool. HSS. HSS means Home Subscriber Subsystem. HSS has all the data related to a subscriber. There could be multiple HSS present in network. LTE network and IMS network may share the same HSS, or they can have their independent HSS. It is implementation dependent. SLF. SLF means Subscription Locator Function. When more than one HSS is deployed in the network, a subscriber location function is needed to locate the HSS that holds the subscription data for a given user. CSCF queries the SLF entity to get the HSS name for a given user. Remember 2 points. Point number 1. All these nodes present in IMS architecture are logical nodes. In actual implementation, few of these nodes can be combined together. For example, usually Media Gateway Controller and Media Gateway are combined in a single node. Point number 2. In this diagram, I have considered only one copy of each type of logical node. In actual implementation, there could be multiple copies of various nodes. For example, in actual implementation, there are multiple CSCF, multiple HSS, and multiple Media Gateway Control function and media gateways in a single network. Now we are done with IMS architecture, but as I said in the beginning, I will try to explain this figure in 2 minutes. Let's do that. UE is connected to PCSCF over GM reference point. Then here is UT reference point between UE and application server. PCSCF, ICSCF, and SCSCF can be combined into a single physical node called CSCF. CSCF acts as a SIP server. Application server runs various applications used for value-added services. HSS has got data related to a user's profile. SLF is used to select HSS for a user. BGCF chooses an appropriate MGCF for call that has source or destination in CS network. MGCF controls the media gateway. Media gateway does the user plane processing for a call that has source or destination in CS network. IBCF controls the transmission gateway. Transmission gateway does the user plane processing for a call destined to some other IMS network. MRFC is used to control MRFP. MRFP is used to do user plane processing for various services such as conferencing, announcements, etc. I have covered only important aspects of IMS network. If you want to study more, here are a few references. Number 1. GSM document FCM.01 should be ideal starting point. This document has got all the signaling flows of various kinds of VoLTE calls. Second very important document is ARIA.92. This document has all the necessary requirements for VoLTE at UE side. It is a very small document but full of knowledge. Third document is 3GPP specification 23.228. Although it is a very big document, but it has got everything about IMS networks. Now you know what is IMS. Next thing is to know how data flow takes place during various kinds of VoLTE calls. In my next video, I will take different types of VoLTE call scenarios into consideration and show you how data flows from one UE to another UE in each case. If you enjoyed this video, please hit the like button and share your thoughts in comment section, guys. and keep waiting for the next video. Please subscribe this channel for such videos in future. Bye bye guys. See you next time.